This is a not too practical example of how to solve a system of inequalities. In this example, Mark has 12 hours to study both mathematics and science. However, he needs to study at least twice as much science as mathematics. So what possible combinations are there? First, define your variables. Since the science hours depends on the number of mathematics hours, we're going to let y be the science hours and x be the independent variable, which is mathematics. Next, we have to determine if there are any restrictions on our variables x and y. In your course, your only possible restrictions that you need to consider are whether x and y are real numbers or must be restricted to whole numbers. Our variables x and y represent hours, and hours can be measured in fractions. So therefore x and y are real numbers, and there are no restrictions. Next, we need to determine the constraints. These are the conditions that x and y, or the hours of science and math, must follow. They can't be negative hours, so therefore x, or the mathematics hours, must be greater than or equal to 0, and y, the science hours, are also greater than or equal to 0. Mark has a maximum of 12 hours to study both science and mathematics. So that constraint is x plus y must be less than or equal to 12 hours. He has to study at least 2 times more hours of science than mathematics. That inequality is represented as y is greater than or equal to 2x. Now we're going to use Geogebra to graph our system. First of all, I'm graphing that x and y must be positive. I've used Geogebra's Move tool to show only the first quadrant where x and y values are positive. Next, I graph the inequality that shows that Mark has a maximum of 12 hours to study. That is, x plus y is less than or equal to 12. The last constraint that I have to graph is that the science hours must be at least 2 times greater than the math hours. That is, y is greater than or equal to 2x. This quadruple shaded area represents the solution set for the system of inequalities. Next, we need to find 3 possible solutions and justify our choices. I'm using the Move tool again so that we can zoom in on our solution set. Possible solutions are here, and I'm going to look at x values that are equal to 1. That is, mathematics is being studied for 1 hour. As I move up the line, I will see the different possible values of science hours that I could study when x is equal to 1 hour. If I study mathematics for 1 hour, the most I can study for science is 11 hours, because I cannot exceed 12 hours total. If I study math for 2 hours, I have to study science for a minimum of 4 hours, and in a similar way, I cannot exceed the 12 hours total. Here I can choose to study 2.5 hours for mathematics. The minimum I must study science for is 2 times 2.5, or 5 hours. Again, I cannot exceed the total, so for studying 2.5 hours of mathematics, the most I can study for science is 9.5 hours. Otherwise, if I study more, I will exceed the 12 hours maximum. The vertex here is significant. If I study 4 hours of mathematics, I must study 8 hours of science to meet the minimum twice as much. At the same time, the 4 hours and 8 hours reaches the maximum hours possible, or 12 hours. There are many possible solutions to choose from, as long as you choose from the solution region. In this example, we're allowed to choose points on the line, because the inequalities also includes the equality. Geogebra shows that the region is bounded by solid lines. That means that we are allowed to choose points on the line.